Download this code from codegive.com, link in the description below. OK, let's dive into the top 10 software security flaws and how to avoid them. This will be a comprehensive guide with explanations, code examples, primarily in Python, as it's a widely used language, but the concepts apply across languages, and preventative measures. I'll be focusing on the owasp top 10 vulnerabilities. Important note: security is a layered approach. There's no single silver bullet. Defense in depth is key, meaning multiple layers of protection. Also, keep in mind that the owasp top 10 evolves, so stay up to date with the latest lists and security best practices. The owasp top 10, most recent version, continuously updated. The owasp top 10 isn't a static list, but here are the most common categories. 1. Broken access control. 2. Cryptographic failures. 3. Injection. 4. Insecure design. 5. Security misconfiguration. 6. Vulnerable and outdated components. 7. Identification and authentication failures. 8. Software and data integrity failures. 9. Security logging and monitoring failures. 10. Server-side request forgery, SSRF. Let's break down each one with explanations and prevention strategies. 1. Broken access control ****. What it is: access control enforces restrictions on what authenticated users are allowed to do. Broken access control occurs when these restrictions are not properly enforced, allowing users to access resources or perform actions they shouldn't be able to. This can range from accessing another user's account data to performing administrative functions without authorization. Example scenario. Imagine a web application where users can access their profile information by visiting a URL like /profile, user_ID equals 123. If the application doesn't properly verify that the currently logged in user owns the profile corresponding to user_ID equals 123, an attacker could simply change the user_ID in the URL to access someone else's profile data. Prevention strategies. Least privilege principle. Grant users only the minimum necessary privileges to perform their tasks. Avoid granting broad admin or super user roles unless absolutely necessary. Centralized access control. Implement a centralized access control mechanism. Avoid scattering access control logic throughout your code base. This makes it harder to track and maintain. Role-based access control, RBAC. Use roles to define permissions. Assign users to roles, and grant permissions to roles. This simplifies management. Authorization checks. Always verify authorization before granting access to resources or performing actions. Don't rely solely on authentication. Knowing who someone is, you must also verify what they are allowed to do. Don't expose internal IDs. Avoid exposing internal object IDs directly in URLs or APIs. Use opaque identifiers or UUIDs. Avoid guessable IDs. Don't use sequential integer IDs for resources. This makes it easy for attackers to iterate and attempt to access other users' data. Logging. Log access control failures. This helps you detect and respond to attacks. Code example, Python with Flask, demonstrating a broken access control example and a fix. Explanation of broken code. The edit_profile function takes a profile_ID from the URL. It doesn't check if the logged-in user is authorized to edit that specific profile. Any logged-in user can change the URL to /edit_profile/1, /edit_profile/2, etc., and modify other users' profiles. Asterisk how to fix it asterisk. Key change asterisk the if profile underscore ID equals user underscore ID check ensures that the logged in user can only edit their own profile. Additionally, consider checking the role to allow only admins to access certain profiles. Never trust data coming from the client, example URL parameters. 2. Cryptographic failures asterisk asterisk. Asterisk what it is asterisk this refers to the improper use of cryptography, leading to sensitive data being exposed. This includes asterisk using weak or outdated cryptographic algorithms. Asterisk improperly storing passwords, example using plain text or weak hashing. Asterisk not encrypting sensitive data in transit or at rest. Asterisk improper key management. Asterisk example scenario asterisk. Storing user passwords in plain text in a database is a classic example. If the database is compromised, all user passwords are immediately exposed. Another example is using a deprecated encryption algorithm like DA, which is easily broken with modern computing power. Asterisk prevention strategies asterisk. Asterisk use strong, modern cryptographic algorithms asterisk avoid deprecated algorithms. Use algorithms like AES-256 for symmetric encryption and RSA with a key size of at least 2048 bits or ECC, elliptic curve cryptography, for asymmetric encryption. Use TLS 1.3 or later for secure communication. Asterisk proper password hashing asterisk never store passwords in plain text. Use a strong, adaptive hashing algorithm like BCRYPT, SCRYPT, Argon2, or PBKDF2. Use a unique, randomly generated salt for each password. Asterisk encrypt sensitive data at rest asterisk encrypt sensitive data stored in databases, files, or other storage mediums. Asterisk encrypt sensitive data in transit asterisk use HTTPS, TLS/SSL, for all communication between the client and the server. Asterisk secure key management asterisk protect cryptographic keys. Use hardware security modules, HSMs, or key management systems, KMS, for storing and managing keys. Avoid storing keys in code or configuration files. Rotate keys regularly. Asterisk don't roll your own crypto asterisk use well-vetted, standard cryptographic libraries. Don't attempt to implement your own cryptographic algorithms. Asterisk follow industry best practices asterisk keep up to date on the latest cryptographic recommendations and vulnerabilities. Asterisk code example, Python, password hashing with BCRYPT. Asterisk explanation asterisk. Asterisk BCRYPT.gen salt, generates a random salt. The salt is crucial, it prevents attackers from using pre-computed tables of hashes, rainbow tables, to crack passwords. Asterisk BCRYPT.hashPu, hashes the password using the salt. Asterisk BCRYPT.checkPu, verifies that a given password matches the stored hash. It automatically extracts the salt from the stored hash. Asterisk important asterisk store the hashed password, returned by #password, in your database, not the plain text password. 3. Injection asterisk asterisk. Asterisk what it is asterisk injection flaws occur when an attacker is able to inject malicious code or data into an application, causing it to execute unintended commands or query data it shouldn't. The most common type of injection is SQL injection, but other forms include OS command injection, LDAP injection, and more. These flaws typically arise when user-supplied input is not properly validated or sanitized before being used in commands or queries. Asterisk example scenario, SQL injection. Consider a web application that uses the following SQL query to retrieve user data. If the username and password variables are taken directly from user input without any sanitization, an attacker could enter the following as the username. The resulting SQL query would become: since 1 equals 1 is always true, the query would return all users in the users table, effectively bypassing authentication. Prevention strategies input validation validate all user input. Check the data type, length, format, and allowed characters. Reject invalid input. Never trust user input. Output encoding encode output to prevent cross-site scripting, XSS, attacks. Parameterized queries. Prepared statements use parameterized queries or prepared statements when interacting with databases. This separates the SQL code from the user-supplied data, preventing the data from being interpreted as code. Escaping user input when using string concatenation for queries, discouraged. Escape special characters in user input to prevent them from being interpreted as SQL commands. Use the escaping mechanisms provided by your database library. Least privilege run your database with the least necessary privileges. Avoid using the root or admin database user for your application. Web application firewall, WAF use a WAF to detect and block common injection attacks. Static analysis use static analysis tools to identify potential injection vulnerabilities in your code. Code example, Python, preventing SQL injection with parameterized queries. Explanation instead of concatenating the username and password directly into the SQL query string, we use placeholders. The cursor.execute method takes the query and a tuple of parameters. The database library automatically handles escaping and quoting the parameters, preventing SQL injection. 4. Insecure design what it is this category represents flaws in the application's architecture, design, and security controls. Unlike other categories that focus on implementation errors, insecure design addresses broader, systemic issues that are difficult to fix with simple code changes. It includes missing or ineffective security controls, flawed threat modeling, and inadequate security considerations throughout the software development lifecycle, SDLC. It's about building security into the application from the start, rather than bolting it on as an afterthought. Example scenario An e-commerce application that doesn't properly consider the threat of fraudulent transactions during the design phase. It might lack multi-factor authentication, MFA, rate limiting, and transaction monitoring, making it vulnerable to account takeover and financial fraud. Another example could be a system that stores all user data, including highly sensitive information, in a single database without proper segmentation or encryption. Prevention strategies threat modeling perform threat modeling to identify potential security risks early in the development process. Identify assets, threats, and vulnerabilities. Prioritize risks and develop mitigation strategies. Secure SDLC integrate security into every phase of the software development lifecycle, from requirements gathering to design, development, testing, and deployment. Security architecture review conduct regular security architecture reviews to identify design flaws and ensure that security controls are properly implemented. Secure design principles follow secure design principles such as least privilege, grant users and components only the minimum necessary privileges. Defense in depth, implement multiple layers of security controls. Asterisk fail securely, design the system to fail in a safe and controlled manner. Asterisk keep it simple, minimize complexity to reduce the attack surface. Asterisk separation of duties, divide responsibilities to prevent a single person from compromising the system. Asterisk principle of least astonishment, design the system to behave in a way that is predictable and understandable to users. Asterisk security requirements. Asterisk define clear security requirements upfront. These requirements should be specific, measurable, achievable, relevant, and time-bound, SMART. Asterisk secure defaults. Asterisk configure systems with secure defaults. Disable unnecessary features and services. Asterisk input validation and output encoding. Asterisk as mentioned in injection prevention, validate all input and encode all output. Asterisk authentication and authorization. Asterisk implement strong authentication and authorization mechanisms. Asterisk data protection. Asterisk protect sensitive data both in transit and at rest. Use encryption, access controls, and data masking. Asterisk logging and monitoring. Asterisk implement comprehensive logging and monitoring to detect and respond to security incidents. Asterisk regular security testing. Asterisk conduct regular penetration testing and security audits to identify vulnerabilities. Asterisk code example, conceptual, demonstrating a lack of rate limiting. Asterisk explanation. Asterisk the code is vulnerable to brute force attacks because there is no rate limiting. An attacker can repeatedly attempt to log in with different passwords until they find the correct one. Asterisk how to fix it, add rate limiting. Asterisk key change. Asterisk the code now implements rate limiting. It checks if the number of login attempts from a given IP address within a specified time window exceeds a threshold. If it does, it returns a 429 too many requests error. 5. Security misconfiguration. Asterisk asterisk. Asterisk what it is. Asterisk this is a very common vulnerability that arises from insecure default configurations, incomplete or ad hoc configurations, open cloud storage, misconfigured HTTP headers, and verbose error messages containing sensitive information. It's essentially about not properly hardening your environment. Asterisk example scenario. Asterisk. Asterisk leaving default usernames and passwords enabled on a system. Asterisk exposing unnecessary services or ports. Asterisk not configuring proper access controls on cloud storage buckets, making them publicly accessible. Asterisk displaying detailed error messages to users, which can reveal internal system information to attackers. Asterisk not using HTTPS for all communications. Asterisk not properly configuring firewalls. Asterisk prevention strategies. Asterisk. Asterisk harden your systems. Asterisk follow security hardening guidelines for your operating systems, web servers, databases, and other software. Asterisk disable unnecessary features. Asterisk disable or remove any features, services, or ports that are not required. Asterisk change default credentials. Asterisk immediately change all default usernames and passwords. Use strong, unique passwords. Asterisk regular security audits. Asterisk conduct regular security audits to identify misconfigurations. Asterisk automated configuration management. Asterisk use automated configuration management tools to ensure that systems are consistently configured according to security best practices. Asterisk secure defaults. Asterisk choose software and platforms with secure defaults. Asterisk error handling. Asterisk handle errors gracefully and avoid displaying sensitive information in error messages. Log detailed error information to secure logs, but present generic error messages to users. Asterisk patch management. Asterisk keep your systems up to date with the latest security patches. Asterisk principle of least privilege. Asterisk grant users and applications only the minimum necessary privileges. Secure storage. Securely configure cloud storage buckets and other storage services. Use access controls to restrict access to authorized users and applications. HTTP headers. Configure HTTP headers to improve security. Use headers like strict transport security, HSTS, to enforce HTTPS. X frame options to prevent clickjacking attacks. X content type options to prevent MIME sniffing attacks. Content security policy, CSP, to restrict the sources of content that the browser is allowed to load. Code example, Python, demonstrating verbose error messages and a fix. Explanation. The original code exposes detailed error messages, like invalid literal for int, with base 10, ABC. This information could be used by attackers to understand the system's internal workings and potentially discover vulnerabilities. The corrected code returns generic error messages to the user, like invalid input. It's important to log the detailed error information to a secure log file for debugging purposes, but don't expose it to the user. 6. Vulnerable and outdated components. What it is. Using components, libraries, frameworks, and other software modules that are known to have vulnerabilities, or using outdated versions of components that have been patched. This is a common attack vector because attackers can easily find and exploit known vulnerabilities in popular components. Example scenario. Using an outdated version of jQuery with a known XSS vulnerability. An attacker could inject malicious JavaScript code into the application and execute it in the user's browser. Using a vulnerable version of a logging library that allows remote code execution. Prevention strategies. Inventory your components. Maintain an inventory of all components used in your application, including their versions. Vulnerability scanning. Regularly scan your components for known vulnerabilities. Use tools like owasp dependency check, SNYK, or other commercial vulnerability scanners. Dependency management. Use dependency management tools, like Maven for Java, pip for Python, npm/yarn for JavaScript, to manage your components and their dependencies. Keep components up to date. Regularly update your components to the latest versions, including security patches. Automated updates. Automate the process of updating components. Monitor security advisories. Subscribe to security advisories for the components you use. Stay informed about new vulnerabilities and security patches. Vendor security. Evaluate the security practices of your component vendors. Choose vendors that have a strong track record of security. Software composition analysis. Use SCA tools to identify vulnerabilities in your software dependencies. SCA tools can also help you understand the licensing implications of the components you use. Code example, conceptual, demonstrating the need for dependency management. Explanation. The example highlights the risk of running a script without including needed libraries. This risk can be mitigated using dependency management such as pip in Python. 7. Identification and authentication failures. What it is. Vulnerabilities related to how users are identified, authenticated, and how their sessions are managed. This includes weak passwords, lack of multi-factor authentication, MFA, predictable session IDs, and improper session management. Example scenarios. Allowing users to create weak passwords, example password 123. Not implementing multi-factor authentication, MFA, for sensitive accounts. Using predictable session IDs, which can be easily guessed by attackers. Not properly invalidating sessions after logout. Allowing session fixation attacks. Prevention strategies. Enforce strong passwords. Enforce password complexity requirements, minimum length, mixed case, special characters, etc. Multi-factor authentication, MFA. Implement MFA for all sensitive accounts. Secure session management. Use strong, randomly generated session IDs. Rotate session IDs after authentication. Set appropriate session timeout values. Properly invalidate sessions after logout. Protect session cookies with the HTTP only and secure flags. Authentication mechanisms. Use standard authentication protocols, example OAuth 2.0, OpenID Connect, SAML, where possible. Implement account lockout policies to prevent brute force attacks. Password recovery. Implement secure password recovery mechanisms. Avoid using security questions with easily guessable answers. Use email or SMS verification. Credential stuffing. Implement defenses against credential stuffing attacks, where attackers use lists of compromised usernames and passwords from other breaches to attempt to log into your application. Code example, Python, demonstrating insecure session management and a fix. Explanation. The example initially uses a hard-coded secret key for Flask sessions. This is a major security risk because an attacker who knows the secret key can forge session cookies and gain unauthorized access to the application. The corrected code uses os.urandom, 24, to generate a cryptographically secure secret key. This key should be stored securely, example in an environment variable or configuration file, and never exposed in the code. 8. Software and data integrity failures. What it is. This category focuses on vulnerabilities related to ensuring the integrity of software and data. This includes code and infrastructure updates without integrity verification, reliance on untrusted sources for libraries, modules, or dependencies, and the use of plugins or libraries without proper validation. Example scenarios. An application that automatically installs software updates from an untrusted source without verifying the integrity of the updates. An attacker could compromise the update server and distribute malicious updates. An application that uses a third-party library without verifying its integrity. The library could be compromised or contain malicious code. An application that doesn't validate the integrity of data before processing it. An attacker could inject malicious data that could corrupt the system or lead to other vulnerabilities. Prevention strategies. Code signing. Sign your code to ensure that it has not been tampered with. Verify the signatures of all code before installing it. Dependency verification. Verify the integrity of all third-party libraries and dependencies. Use checksums or digital signatures to ensure that the components have not been modified. Software bill of materials, SBOM. Generate an SBOM for your application to track all of its components and their versions. This helps you identify and address vulnerabilities in your dependencies. Data validation. Validate the integrity of data before processing it. Use checksums, digital signatures, or other mechanisms to ensure that the data has not been tampered with. Asterisk secure update mechanisms. Asterisk implement secure update mechanisms that verify the integrity of updates before installing them. Use HTTPS for downloading updates and verify the digital signatures of the update packages. Asterisk configuration management. Asterisk use configuration management tools to ensure that systems are configured consistently and securely. Asterisk immutable infrastructure. Asterisk use immutable infrastructure principles to prevent unauthorized modifications to your systems. Asterisk code example, Python, demonstrating integrity checking of a downloaded file. Python. Import hashlib. Import requests. Def download underscore file, URL, expected underscore SHA-256. Downloads a file from a URL and verifies its SHA-256 hash. Try. Response equals requests.get, URL, stream equals true. Response.raise underscore for underscore status, raise an exception for bad status codes. Hasher equals hashlib.sha256. With open, downloaded underscore file, WB, as file. For chunk in response.iter underscore content, chunk underscore size equals 4096. Hasher.update, chunk. File.write, chunk. Downloaded underscore SHA256 equals hasher.hex digest. If downloaded underscore SHA256 equals expected underscore SHA256. Print, file downloaded and integrity verified. Return downloaded underscore file, return the file name. Else. Print, error, file integrity check failed. Return none, indicate failure. Accept requests.exceptions.request exception as E. Print, F error downloading file, E. Return none. Accept exception as E. Print, F an unexpected error occurred, E. Return none. Example usage. File underscore URL equals https://example.com/myfile.txt. Replace with the URL you want to download from. Expected underscore SHA256 equals E5B7E9F0F9E1F9E8F7E6F5E4F.